Hi, my name is Aqilah binti Mama Johar, kat matric B0821103448. I will show you how to construct the circuit using a simulator. First, click on draw, go to the network and select bus to insert bus 1. Set the nominal voltage to 13.8 kV. Click on the bus information and click System Select Bus and select OK. Go to the format and display size and choose down, select OK. Go to the network and choose bus and repeat step 3 to insert bus 2. Next, choose network and select generator. Insert generator at bus 1 and set the power at set point 8 MW and reactive power at 4.0 kV. And choose format and select display all size and choose left, select OK. Next, go to network and insert transmission line from bus 1 to bus 2 and set the resistance value 0.5 and reactance 1.0 and MVA limits is limit A, which is 50, and select OK. Right click on bus 1, select add new field around bus, choose post 6 and select the bus voltage kilovolt to display bus voltage at bus 1. Next, insert load at bus 2 and set constant power at 8 MW and 4 MVAR. Double click on load megawatt field, set the digit right of decimal, which is 1. To see more digit in the load field, set the data per mouse click field to 1.0. Select OK. Repeat step at megawatt to MVAR load, which is digit right decimal is 1 and data per click 1.0. Select OK. Next, insert a switch shunt at bus 2. Position the switch shunt must be parallel with the load. Set the nominal value. Set the nominal value is 0. Choose decrease and set the number of step is 20 and MVR per step 0.5. Select OK. Next, we go to the background and choose text and add text in one line, which is like a generator and the other components. Next, we go to the shunt and VAR and choose the digit right of decimal, which is 1, and data per click 1.0. Select OK. Right click and choose the one line and choose the animated and select the actual megawatt and VAR. So now I will start with 0 MVAR. Generator will be 5 megawatt. I will show how to demonstrate the circuit. So if we vary the value of the shunt capacitor, we can see that the reactive power losses at generator and the voltage will be changed in transmission line, especially at bus 2, and the load value still the same. If we change the value at the shunt capacitor, it will affect the power losses and reactive power losses. There will be no change at the real power losses and reactive power losses. Let's say if we adjust value at shunt is 1.3 and 1.7, there will be a 0.02 megawatt losses and 0.0T MVAR losses. So when we reach 3.6 above until 5.7, there will be no change at the real power losses. The value still the same.
Hi, my name is FIRDAUS. Now I will explain the circuit. Firstly, I will explain the circuit while the switch shunt in 0.0 MVAR. In this condition, the generator supply 8 megawatt and 5 MVAR or 4.968 MVAR. The power flow through bus 1 is 13.8 kilovolt and the power flow through bus 2 is 12.56 kilovolt. The power through the load is 8 megawatt with 4 MVAR. Okay, now I will explain what happened to the power and reactive power while we change the switch shunt from 0 to 9.1 MVAR. In actual switch shunt, which is 0.0 MVAR, the power losses on transmission line is 0.48 megawatt and reactive power losses on transmission line is 0.97 MVAR. If we increase the switch capacitor, we can see that the power losses on transmission line become 0.46 megawatt and the reactive power losses on transmission line is 0.92 MVAR. In this condition, we can conclude that they have 0.02 losses on power and 0.05 losses on reactive power on transmission line. So at the 3.6, the power losses on the transmission line we show at 0.35. If we increase value at shunt is 3.6, the real power losses will be 0.35 megawatt. So this is starting the line with the blue arrow, which is reactive power losses display. The flow current is low through this generator. Generator cannot produce the MVAR, but the shunt create the MVAR. If we decrease to 4.1, the power losses still remain 0.35 and reactive losses still 0.7 until show at the value 4.6, the error of MVAR start to reverse back at the generator. This is because the shunt has increased more value than the load. So if we increase more, the generator cannot provide more MVAR, but the shunt will. If we increase shunt at 6.2, the real power and reactive power losses will increase. The error of MVAR start to reverse back to the generator. This is because the shunt has increased more value than the load, which is 4.6 and 4.0. So the remaining 0.6 has transferred to the generator. So if we increase more, the generator cannot provide more of MVAR, but the shunt will. If we increase shunt at 6.2, the real power and reactive power losses will increase. That's all for me. Thank you.